Welcome viewers, I am Venkatesan. Today my lecture is about binomial distribution. The question is, find the moment generating function of the binomial distribution and hence find its mean and variance. Solution. First, let me define the probability mass function of binomial distribution. That is, P of capital X is equal to small x is NCX P power X Q power N minus X, where the total probability P plus Q is equal to 1. Now we are going to determine its moment generating function. We know that mx of t is equal to expectation of e power tx, that is summation x is equal to 0 to n e power tx into ncx p power x into q power n minus x. Since this binomial distribution comes under discrete random variable, we are considering summation here. If it is continuous, we are supposed to use integration symbol here. Now we can simplify this. Here e power tx p power x. In these two terms, I am taking the power x common. So here it will be p e power t whole power x into q power n minus x. All remaining terms are same. The next step, apply x is equal to 0, 1, 2, etc. up to n. When I replace x value with 0, I got nc naught p power t whole power 0 into q power n minus 0. Plus, when you apply x is equal to 1, you will get nc1 p e power t whole power 1 into q power n minus 1 plus etc. up to x is equal to n, which indicates ncn p e power t whole power n into q power 0. Here we know nc naught p e power t whole power 0 both will be 1. Next, q power n minus 0 will be q power n. Next, here nc1 everything will be the same. nc1 p e power t whole power 1 will be p e power t, q power n minus 1 will be q power n minus 1. Similarly, the last term ncn will be 1, q power 0 also will be 1. So the remaining term is p e power t whole power n alone. When you simplify this, you will get p e power t plus q whole power n. So this is moment generating function of binomial distribution. That is, mx of t is equal to p e power t plus q whole power n. Now we are going to determine its mean and variance. Remember, from moment generating function, we are going to derive mean and variance. How to derive mean and variance from moment generating function? The formula for mean is E of x, that is expectation of x is equal to differentiation of its moment generating function at t equal to 0. When you differentiate moment generating function once and if you apply t equal to 0, you will get its corresponding mean. Similarly, for second moment, E of x square, the same moment generating function we should differentiate twice. Mx double dash of t at t is equal to 0. Then how to determine variance? We know that variance of x is equal to E of x square minus E of x whole square. So using these three formulas, we are going to determine mean and variance. First, to determine mean, we know E of x is equal to mx dash of t at t equal to 0. Here is mx of t, differentiate it once. It looks like differentiation of x power n. We know that d by dx of x power n is n x power n minus 1. In the same way, here n x value power n minus 1 into differentiation of this x with respect to x is 1. Similarly, this differentiation of p e power t plus q will be p e power t at t equal to 0. So when you replace t equal to 0, you will get E of x is equal to np. That is mean value of binomial distribution. Why? Because here we have p plus q. We already considered p plus q value is 1 here. The first step itself we assumed p plus q is 1. That I am replacing here. Next, we are going to determine its second moment, that is E of x square, which means mx double dash of t at t equal to 0. The same moment generating function I'm going to differentiate twice. We can simplify it using product rule. You consider this value as u and this value as v. We can take this p and n constant, we can take it common here. So we know the formula, d by dx of uv is equal to u dv plus v du. I am using product rule here, u dv plus v du here. When you simplify, when you apply t equal to 0, you will get np plus n square p square minus np square. We know the formula for variance, that is e of x square minus e of x whole square, which means np plus n square p square minus np square minus n square p square. We can cancel n square p square with n square p square. So you will get np into 1 minus p. We know that 1 minus p value is q. Why? Because p plus q is equal to 1, that we already assumed. Hence, the variance value is npq. In the next lecture, we discuss about Poisson distribution. Thank you.